Okay, thank you again. Yeah, so today we're going to talk about some of the best practices that Google has related to security, specifically around APIs in your application. If you want to go to the next slide. Yeah, that's right. There we go. So when you think about, when you think about the last 10 or 15 years, there's been an explosion in the number of commercial products that rely on other products, a lot of integrations, a lot of mobile devices and other systems that are building upon others, right? So there's a lot of open source software, there's a lot of services you want to consume. And oftentimes it's done using some sort of an API. What's happening in the industry today is because of this access to these integrations with these APIs, systems are being able to be built faster and better. But it does come at the challenge of certain challenges. So, for example, business continuity, being able to sustain yourself during outages from your vendors or your systems, making sure that you have appropriate backup and recovery strategies, reusability and ownership, being able to decide, for example, say you're using an API to verify credit card information and you want to switch vendors, being able to do that easily and also reuse it in different systems. Also, there's in some systems there's tight coupling between the front end and back end, and you want to modernize, but you don't have the cycles to re-architect the whole system. So oftentimes you see where APIs are being used to provide a proxy layer between your traditional sort of three-tier system and your downstream clients, so that you have a buffer or a facade that allows them to interact using modern software approaches, while you are able to keep your systems and update them as your business demand accounts for it. Security, which is a big part of this conversation, more and more you're seeing threats to your application from phishing, from bot attacks, from malicious actors, spoofing, things like that, and you need some way to protect yourself, and denial of service attacks, things like that. You needed some way to protect yourself in your business from these systems. Interoperability, being able to work with other systems easily. I talked a little bit about that, as well as providing essentially a single pane of glass to sort of monitor your operations and understand how your systems are being used, who's consuming it, what partnerships are more lucrative than others, what locations where you're getting data from in terms of use is better for your business. Analytics as well is an area that's growing. Next slide, please. So these are some of the challenges with application development, with API development. And when you think about life before we had API management tools or capabilities, it was very much point to point, where there was a lot of development going on, but not a lot of coordination. Operations teams struggled to keep up. Depending on your systems, you might have certain vulnerabilities where certain APIs are exposed that allow, from a front end to go all the way to your back end and maybe have access to confidential information or expose PII or other information. And you want to be able to restrict it. You want to be able to do things like remove PI from information. You want to be able to do things like identify security threats and as well as vulnerabilities, bot attacks, things like that. But it was very difficult because of the nature of how things were being developed. Next slide. So when you now start to look at where some of these modern API management systems, as I mentioned, they act as a facade for your front ends, so that behind the scenes, you can make modifications and change. You can version control your API. So if you have clients that are on an old version or you want to upgrade to a new version, you can send them to specific URLs and allow your development to progress, 2, 3, 4 cycles while your legacy customers are evolving or learning to adopt the new technology. You also have the ability to monetize these APIs in terms of rates and things like that, based on the amount of traffic that's being generated by a given customer or by a given downstream system. You have the ability, as we talked about, to implement better security protocols and practices. So with an API management system, it gives you much more visibility, as well as solving some of the other challenges. But a key thing that I think many other organizations, as we talked about Anthos earlier, as we talked about microservices in earlier sessions, these are all different approaches to solving essentially the same problem. How do you increase your velocity of your software development teams while mitigating the risks of downtime? API management systems are uniquely positioned to help you do that, because behind the API management system, you might have a system of record that's built on top of a mainframe. You might have new development applications that are Kubernetes based with microservices. You might have client tier or even SaaS apps that you're reusing, and you're providing a single pane of glass or a facade that allows you to present yourself to the world as a united modern application. And you might have behind the scenes some things that need to be addressed from a security standpoint. Again, API management acts as that layer to help shield you from certain attack, like denial of service attacks, things like that. We go to the next slide. So here's some of the common threats that I think many of you have seen. Denial of service attacks, as I mentioned, competitors scraping prices or other data off of your systems, abuse of guest accounts and other types of free accounts, bot attacks that skew analytics as well as degrade your performance. You have other types of compromise, where you might be sharing API keys or other things that other security breaches that allow a bad actor to get access to your backend data, and maybe even compromise your systems. So again, these are some of the attacks that in the list and types of security threats are growing. It could just be a developer who made a mistake, or it could be a targeted attack against your system. It doesn't matter. In either case, API management providing the level of security on top of what you're already doing is another layer that prevents those types of threats. If you go to the next slide. So I'm going to go through some best practices that Google has for some of the challenges that we've talked about. The first best practice, and I think most people know this as well, is you want to take a holistic view. You want to start and look at the end-to-end for your specific type of application or system. Look at it from an end-to-end and identify where your possible threats are coming from. Is this what type of system? Each types of systems, whether it's retail or marketing or federal, has certain types of threat profiles that are linked based on the type of users and abuse that could occur. If you go to the next slide. So the key thing is first adopt a policy of understanding from an end-to-end cycle, and then understand where your key, not every application will have these types of threats, but here's an example. You might have customer where you're having identity and access. So you might have to implement certain approaches, for example, certain approaches to eliminate or to reduce the amount of security with two types of authentication, where you might have networking access or permissions, in terms of which zones, regions, IP addresses that you will even receive traffic from. You might have developers who have certain access and permissions to prevent them from doing anything malicious, where you have for certain APIs, for certain types of services, restrictions on who can access what. You might have the need to prevent, as we talked about, denial of service, bot attacks, things like that. So again, best practice number one is understand how your system is being used, understand how the APIs have been sort of architected and organized, and then create an assessment of your threat profile of your attack surface, and adopt a strategy to address them based on how you prioritize your threat profiles for each of those types of threats. If, for example, you have a system that's open to the public where you have the potential for a large volume of traffic, and there's bots, then denial of service and being able to identify bots and other types of automated attacks. You might have systems where you have a large amount of CPU usage. You want to prevent essentially Bitcoin mining or other types of misuse of your corporate assets. It really depends. But the key thing is, best practice number one is to understand your system end to end, model out high level attack surfaces, and then address them as from a priority standpoint. Go to the next slide. Some of the capabilities, you can go to the next slide. I'm sorry. So some of the capabilities that Google offers to prevent, for example, in this case, denial of service attacks is a product called Cloud Armor. It's essentially paired with your global load balancers, and it monitors traffic, and you can identify rates. You can have in terms of request rates and how, and provide back off signals to the appropriate systems. You could just have if you're suffering from somewhat of a denial of service attacks, you can just have the traffic dropped. It has different capabilities depending on need. I'm just going over some of the high level ones. But again, going back to your threat profile and your attack surface, if one of your concerns is large volume of traffic impacting your real users, the things that bring you money, looking at some type of a Cloud Armor or denial of service attack solution is something to consider, right? Next slide. CDN and others. There's also within Google, there's capabilities where you, for many people have heard of it, it's called reCAPTCHA, but there's a capability where, I don't know if you've ever gone to a website and you've logged in, and then the next time you log in, and say you logged in unsuccessfully, and then the next time you attempt to log in, you're now being presented with a puzzle or some type of, rotate this dog or this image so that it's in the right order, or pick out the number of camera lights or the number of cars, some system to ensure or to help the backend system ensure that it's not a bot trying to access your account, but is in fact a human. Products like reCAPTCHA. There's another capability that Google has called web risk, which is a capability where when you receive traffic from certain locations, it'll identify that as a possible threat vector based on the historical data of what's been captured by Google search and other Google capabilities. So essentially what it's doing is it's using AI-driven approach to say, we received 5 different threats from across, or 5,000 different, threats from this URL. We now deem this as a high likelihood of some malicious actor. So you can use web risk to help inside your system identify essentially zip codes. We think about them, IP addresses and regions where you will and won't accept traffic from, or you might route it to someone, a human, to be further processed, to put them on an allow list, things like that, so that you don't, restrict all traffic from a region or an area. But essentially, to what we were talking about, you have the ability to do a couple of different things in your front end when you're first receiving it at the API is use um, something like Cloud Armor to prevent bot attacks as a initial preventative measure. Analyze the threats as these URLs and the type of threats. Implement something like reCAPTCHA to use that to make sure that you're filtering out all of the bots or so that you only are getting the human traffic. And then if it is some type of malicious, for example, you might have links that are being spoofed, use tools like WebRisk to further identify actors that are more advanced than just a bot, that kind of thing. But there's multiple ways of solving, and there's multiple layers you might have to implement depending on how you're being assaulted, that kind of thing. If you go to the next slide. Yeah, we can skip this one. This is some more details. So when you get these slides, what I did was, I don't want to go through all of the sort of feature slides, but I put in some of these slides just so that you can see some of the capabilities that you could use. Adaptive protection is similar to what I was talking about, where it's looking at the information coming in and it's using an ML-based attack to detect and respond. And this is a part of Apigee as well. So depending on the systems, there will be capabilities that you may want to use. A lot of my clients are finding that AI, especially in the area of threat identification and quick response, especially to an initial attack, has been able to blunt some of the higher outages or problems from a very quick spike or massive threat vector, that kind of thing. Next slide. Another if you go up this a little bit more, that's fine. The blue side, you can skip the blue slide. Another capability, which is Apigee, which is our Google's API management solution, is partnered with some of these other products, as I mentioned. And so essentially, when you look at Apigee, what Apigee is doing is it's providing you with API management, it's providing you with security. It has monetization features so that you can identify URLs or APIs that are that could be very revenue producing because of the amount of traffic or the amount of need. You also have dashboarding and reporting so that you can see the state of usage, to understand if you need to increase certain capacities and other things from a cloud storage or a cloud consumption in order to support certain types of APIs, things like that. It provides a lot of capabilities on top of just acting as an API gateway, essentially. So many organizations implement a gateway. Apigee is a gateway plus, and in addition to Apigee, there's tools like Cloud Armor, as well as reCAPTCHA and things like that. Next slide. Apigee in itself is an enterprise global solution. It can deploy it anywhere, and it's very close to, like for example, it's in 37 regions in 113 different zones within Google. There's also a SaaS product that is deployed in different locations throughout the world, so that you can get access quickly. You can have multiple, so that the Apigee will work such that the closest location will access when you're making a request. It'll be routed to the closest location for an Apigee instance to reduce any latency or performance issues, that kind of thing. Next slide. So the second best practice is to ensure that between your client and your API system that you've implemented two-way authentication, layer security, things like that, to prevent any of your data to be lost in transit over the public internet. And that's essential. I think most people understand that as essential. And again, many websites they don't require it, but as you grow and look at what's being sent across the wire, credit card information, PII, other informations, making sure you have not just one way but two-way TLS is becoming much more of a business critical standpoint. Next slide. So here's just an example of a typical system that's making use at a high level of Cloud Armor, Apigee, as well as load balancers to provide the access. It's a high level view from one of my clients that I've worked with in the past. Next slide. Best practice number 3, and in the earlier sessions, I think some mention was made of FedRAMP. Because I was listening in, and this is not a part of this slide deck. I'll send you a new slide deck, Ron. I added, and Apigee is FedRAMP moderate compliant, not high, but moderate compliant. I included the link on the, I added to my original deck the link, and I'll send it out. It also is it's also PCI and HIPAA compliant as well. I included the links to the Google sites that provide more details. But the third best practice is, depending on where you're deploying, each of these countries, even to some extent states in the U.S., for example, California may have different compliance rules than New York or Florida. You have to adhere to, and so having a system that can actually be developed to support different compliance requirements in different regions is another reason why you may see benefit in using something like an Apigee, an API gateway, because depending on the region, the fines and fees for not meeting these compliance are quite high. And if you want your systems to work in certain countries and certain regions, then being able to distinguish the fact that there's compliance rules, there's guidelines that they may adhere to, and not have to incorporate all of that into your backend systems, maybe some labor savings for you as well. Next slide. So this talks a little bit about the privacy, and I think we talked in the earlier conversations when Anthos was brought up about data sovereignty. Many organizations like in Europe, for example, GDPR would require certain data to be resident in certain countries and not exposed. Apigee can provide some level of that in terms of being able to route traffic to the appropriate region. Data protection in terms of controls for access, authentications, and API key management, things like that. Data loss prevention, essentially PII, sort of data masking or translation of say social security numbers into XXX so that you're not sharing certain information, as well as we talked about compliance. Next slide. I just included some additional definitions. For example, this is what when we talk about PCI as well as HIPAA, I sort of put in here. But again, in the updated version of this deck, and I'll send it to you, Ron, I included the actual links to the Google documentation on these topics, so you can read that for yourself. Or if you have any questions, as Ron said, even after this session, I'll be available to answer any questions, things like that. I think Ron can connect us, and then I can provide you with whatever update you're looking for, or at least point you in the right direction. Next slide. Yeah, you can skip that one too. Yeah, if you go to the next slide. So best practice number 4 is establish a multi-layer API security. So when you look at modern systems, and we talked about the attack surfaces, there's multiple, there may be a data grab, there may be denial of service, There may be compliance issues. There may be just general auditing and access policy problems. You need to establish at multiple layers in your solution um, security. You need to identify, for example, API key rotation, or being able to have fine-grained control of who can do what um, with your APIs. Or we talked about TLS, or web tokens, or if you're looking at it from a standpoint of being flooded, uh, denial of service, at scale, things like that. Uh, or if it's generally back office, there's also some other customizations along. There's a module within Apigee called Advanced Security that provides even an additional layer for highly that are required made by many highly secure organizations. I didn't cover it here, but I can provide information on that if anyone's interested. But again, a lot of it is, Apigee from a gateway management system is agnostic. It can support. I have clients that are using it on AWS. I know of at least one client using it on Azure. The actual backend systems are in other clouds, and Apigee is providing that gateway or API management protection across multiple clouds. And it's a different approach to Anthos, but it is also used with Anthos in some cases as well. It depends on the situation and the client requirements. Next slide. Next slide. So again, with Apigee, you can identify threat protection policies that you can then implement and monitor and track with dashboards and logs. You can inject regular expressions and other things to validate and test, as well as you can implement spike arrests or other preventative measures on specific APIs so that you can avoid bot attacks or to eliminate denial of service attacks, things like that. But again, the content level security is based on the specific API. Some APIs may only need a minimum level of security, but these policies, once created, can be applied across multiple API instances, essentially. So it allows you to reuse some of the information or some of the security policies that you create as well, which also I find is a benefit for many of my clients. Next level. Next slide, please. This is just showing you an example of spike arrest where you can set a rate limit on how much traffic you're going to allow in a given interval of time. What happens to the traffic that is denied is also left up to you. You can just drop it in some cases, or you can have signals sent back to the client, or saying to throttle their traffic because of the the amount of traffic coming in for, say, 30 seconds or a minute or whatever. But essentially what you're doing is you're making a decision as to how much traffic a given IP or a given API can handle, so that your backend systems aren't being overloaded and flooded. And it could cost you money as well, just to receive traffic that you can't process. Next slide. You can set quotas as well on APIs, so that you can allow a certain amount of traffic and then deny the rest. I actually find using rate limits more than quotas. I don't have many clients that have specific buckets of use for requests, but ultimately it really depends on the use case. And many clients find quotas as a way of ensuring they can get some traffic from all their clients versus getting most of the traffic from one client and basically starving the other ones. But again, it really does depend on the use case, as well as how you're implementing security across the end-to-end cycle. Next slide. Best practice 5. So when you think about what we talked about, the first thing was from a API management standpoint, you can use APIs to provide that layer between your end customers or your systems that you're integrating with and your backend systems, and you can use those so that you can evolve them. We talked about some of the best practices about attacks, about understanding your threat profiles, and we talked about in specifically with API certain types of security measures, and as well as some of the Google tools, like Cloud Armor or reCAPTCHA or Apigee to help support that. When we look at the fifth best practice, it's really about you need an operational team that's there monitoring, regardless of whether you have an API system, you need an operational team in any ways. But the operational team using API management, you need to collect data and monitor your API systems, especially if you're trying to monetize it, especially if you have a history of security or problems where you're getting security breaches. Having API platform, and in some cases, when the case of Apigee, the monitoring is enhanced with ML searching and other things to help you quickly diagnose or provide preventative measures. You want something to help you that because what you find is so much of your traffic is noise, and it's only when you get to at scale and you can see um, the bigger picture that you can identify threats or security breaches, things like that. The one-offs are hard to go, but by having the monitoring and logging and other capabilities, so if you have an essential, if you have a system with a very good API management system, you'll have all five of these capabilities built into one system. In some cases, you have to augment it because maybe for other reasons you have different needs. But essentially, those five best practices are the ones that I found provide the most bang for the buck with my clients. Could you go on one more slide? Here's an example of a high level example of a dashboard, showing the number of connections coming in, showing the amount of traffic, as well as identifying threats that need to be taken care of. Single pane of glass, quick glance, with the ability to drill down to get more details and have actionable steps that can be taken is the goal. I think that's it. If you go one more slide, I think we might be done. Um, yeah, that's just another example of a chart. Depending on how you like, some people like tables, some people like graphic charts. Depending on how you like to see your data, the dashboarding and reporting can be configured based on your needs.